Chapter 2 is split into 3 sections. One is looking at landscapes and how do we interpret those. The second section is how do we depict the Earth's surface in maps and in cross-section. And well, I guess it's 4 sections because then we look at the scientific method, but how we investigate and quantify things in geology. So then the scientific method. So we'll look at those parts now. This is a cliff in Canyonlands National Park in Utah, kind of near, it's near Moab. And in Canyonlands National Park, there are great cliffs of rocks, and then there is active erosion. So if we're looking at this cliff, we would see a couple of things. One, there's different colors. Two, there's slopey areas and vertical cliffy areas. And on those vertical faces, there's big fractures. There's also horizontal layers, and we see that there are rocks, but there's also a curtain of sediment at the base of the rocks. So a geologist would look at that picture, see the various colors, see that there are ledges that reflect the layers, see that there are rounded corners to the cliffs. There are also angular corners. There are loose pieces of sediment. There are colors that look like stains on the outside of the rock. So then if we were going to take that image and try to kind of sketch it, we would do something like this. And in those sketches, you're kind of making an interpretation, right? You're drawing out the horizontal layers, you're outlining the fractures, you're making it clear that there are different colors. So on this diagram, there's 1, 2, 3, 4, 5, 6. That's actually indicating the interpretation of the ages. So for layers 1, 2, 3, 4, and 5, those are sedimentary layers with 5 being the oldest layer, followed by 4, by 3, by 2, by 1 is the youngest layer. 6 is then that curtain of sediment eroding off the cliff. So that's actually the youngest feature in the landscape. Here's another landscape. This is Monument Valley. It's south and south and maybe a little west of Canyonlands. And in Monument Valley, there are these really unique landforms. But what I want you to see in these landforms is that this massive unit here of sandstone actually is the same unit as this, the same unit as this, and the same unit as this. That at one time, all of those layers were connected. So it would look something like this. This is also in Monument Valley, but if we erode it back, if we were to erode that more, it would start to look like this. Okay, so let's look at this landscape. So here I have that massive sandstone, a finely layered, it's actually a siltstone in here, and then these aprons of sediment. So here's the interpretation then of that outcrop. On this image then, we've outlined the thinner layers here. We have the massive sandstone here. There are ledges up above that are, if we go back, you can see they're finely bedded like the siltstone on the bottom. And then there's those aprons of sediment. And then angular blocks that have fallen off the reddish brown cliff above. And then in the foreground, then there's sand and bushes. So here is kind of an interpretation question. So, dogs. Which location contains rocks that are in place or part of the bedrock? So looking at the image, 1, 2, 3, 4, which rocks are part of the, are in place? So that would be, let's let you look at it for a second. A, 1 and 2. Okay. All right. Looking at sediment, sediment is going to have different makeup, like what is it made out of, it's also going to have different textures. And here we have a rock on the left. So here's a rock. And that rock, there's a pin here for scale. That rock has these round rocks in it. We call those round rocks cobbles, and they are classed and they're round. So that rock type is called a conglomerate. If we look over here to the what would be maybe the modern equivalent. So on a steep mountain front, we have these angular rocks. Here's another pin for scale. And then at the bottom, here's a stream channel. So does the rock that we found, this conglomerate, look like the sediment found at on front of a mountain, or does it look like the rocks found in a stream? A stream, right? So these rounded rocks look really similar to these rounded rocks. We call those clasts, and those are conglomerates. In the desert environment of the Southwest, we have these big stacks of what we call layered cake stratigraphy. The oldest rocks are on the bottom, followed by younger, and the youngest are on the top. Over time, that erodes, and it looks like this landscape. Given more time, it looks like this landscape. So the current landscape is this lumpy, bumpy, disconnected swirls of colors. But if we go back in time, it actually was at one point one cohesive block. So that's what I was talking about here, how those massive sandstones were once all connected in just a layer of sandstone. Okay. All right, so some of the principles in geology, and we're going to go over this again when we talk about geologic time. Again, the oldest rock unit is on the bottom, so this tan unit is the oldest, up to the youngest, which is the pink unit. So here, this is back to North Dakota, the older unit is on the bottom, and then we go up to the younger, and then the youngest unit at the top. The next principle is that of cross-cutting relationships. We have a geologic feature, in this case it's a fault, that is cut through 3 layers. We know that the fault has got to be the youngest feature in this diagram because it cuts through the other 3. Here is a fault that cuts through the base of the big mountain chain in the Tetons. That fault then has to be younger than the rocks around it. Another, this one can sometimes be confusing, principle is that if there is a rock unit with pieces or clast of the older unit, we know that that younger unit has ripped up pieces of that older unit. So a younger rock can have pieces of a pre-existing rock in it. In this one, we have this large tannish unit here is a intrusion of igneous rock. So magma, molten rock came into those other units. It was liquid. As it was cooling, it actually baked the edges of the country rock, the pre-existing rock. So this fuzzy line in here is just showing that it's cooked the edges and cooked the pre-existing rock. That's called contact metamorphism. In this image, there's some rocks here, and there's magma coming in, and there's a bit of a baked zone here in Yellowstone National Park. So it bakes the rocks at the edges. Okay, here is a igneous intrusion that is intruded in, and it's cooked some of these sedimentary rocks around it. And it's also ripped some up and incorporated them into the igneous intrusion. All right, so here is a little question. What's the oldest unit or feature in this figure? Is it rock unit 1, rock unit 2, rock unit 3, or the fault in number 4? What is the oldest? 3, right? Rock unit 3. And the youngest would be the fault at 4.